Hi everyone, we're going to look at section 1.6 rational expressions and doing operations with rational expressions. So first thing I want to do is really emphasize the importance of reading the textbook. I don't require that you turn in all the notes and textbook try it problems. That's one choice, but you also have a choice where you could turn in video notes. You really should be doing both components. You just have a choice of how you submit. So I don't want you to think that I don't think the book is important. It really is critical. So you're going to get a lot more comprehensive information than you would see in just an example being done out with some ad-libbing. So for a table of contents, I would click that plus, and then I could go to prerequisites in 1.6. So you pull that up. And then once you have it there, you can click the minus up there to get back. This is in the ebook. I clicked the most current version, which is pretty much the same, other than they made corrections. So here is simplifying rational expressions. Actually, first we have a example of an application, which we'll be doing more and more of in class. Then some just steps for simplifying and how to. So a rational expression is when you have a polynomial in the numerator and one in the denominator. Remember, a constant can actually be a polynomial also. So we did an activity in class in the Math 140 hybrid that we talked about canceling and what's bad canceling. So really be careful, but do go through. Some of these are just exactly the same as what I do in videos, very similar, but take a look at them and read, some of the steps, and that may help you. You can see the solution. So for example, 3, dividing rational expressions, and you can click show the solution, get all the steps. And then below there's a try it problem. And the answers to that I post in the assignment. Again, here's some things, I've talked about on and off and lowest common denominators for adding and subtracting, but it's there in your book. So even if you think, well, I've got this down, just kind of take a look at it at least. That's the idea with you don't have to do every component of everything, but at least look at it. All right, so I'm going to go and do some examples now. So I've switched over to the video companion worksheet 1.6. It says notes, examples, and practice rational expressions. So we have simplify each expression. Number 1, 6x squared minus 54x, all divided by x minus 9. So my first step would be to simplify, because we cannot we cannot cancel terms with terms. We have to just reduce or quote-unquote cancel factors with factors. So I have to get them as a product in this numerator if possible. If not, I just leave it. We're not able to simplify it. That sometimes happens. So if I have the numerator 6x squared minus 54x, I would simplify that to 6. So I'm going to factor out a 6. I also can actually factor out an x. So I have 6x times quantity x minus 9. And then all divided by x minus 9 in the denominator. Now I can see that x minus 9 would be over itself, so I would have 1 that reduces down or quote-unquote cancels, and the answer leaves me with 6x. So that's my final answer on that. Now you might like to try this one on your own, especially if you've already kind of read through the book. This is review, or you came to class for the hybrid. So here we have a multiplication problem. Number 2 reads 6n plus 54, all divided by n plus 9 in the denominator, times numerator n plus 7, and then all divided by 6 in the denominator. So first step would be to simplify anything that you can, and then see if you can reduce. And you can do any numerator with any denominator, even if there's, say there were 3 or 4 fractions across, you could still, kind of skip over some, but as long as it's a numerator with a denominator. So pause the video and try that if you want. I'm going to go on and complete it. So I would have this first fraction. The numerator would simplify to 6 times n plus 9, all divided by n plus 9, times my other fraction, n plus 7, all divided by 6. So I can simplify the 6 in the numerator with the 6 in the denominator, even though it's on the diagonal. That's fine. And then the first fraction there, I have n plus 9 over n plus 9. So that reduces to 1. So ultimately, I'm left with n plus 7 as my final answer. Number 3 reads 2k squared divided by quantity k minus 7. And then that's one fraction. Then there's a division symbol. The second fraction is 3 over quantity 21 minus 3k. So the first thing I'm going to do, just so I don't forget, is change this second term. So I'm writing 2k squared over k minus 1 is the first term. And then I'm going to multiply by the second term. I'm going to change it around to its reciprocal, 21 3k divided by 3. As dividing fractions, you need to multiply by the reciprocal. And sometimes if you just start right off factoring things, it's really easy to forget to flip it. So I am going to right up here off to the right a little bit. I'm going to factor anything that I can. The 2k squared over k minus 7 just stays. I can't factor anything in there. In the second fraction, 21 minus 3k, I can actually pull out a 3, leaving me with 7 minus k in the numerator. And then all divided by, with that fraction bar, over 3. Now I can reduce any common factors. So I have a 3 divided by 3 in the second term. That becomes 1. The other thing I have here is 7 minus k in the numerator of the second fraction and k minus 7 in the denominator of the first fraction. Now those are really close. I could work with that a little bit. I can rearrange the 7 minus k to be minus k plus 7, and then I can actually factor out a negative 1, which would give me a k minus 7. So now I can actually reduce that k minus 7 in the numerator with the k minus 7 in the denominator. But don't forget that negative 1. Okay. So when I rewrite this, I now have negative 1 times the 2k squared, giving me negative 2k squared. And then don't have anything left in the denominator, so I just leave it as that. So a little rule: if you have a minus b over b minus a, that equals -1. So a quick way to do this would have just been reduce it out and write -1. But I wasn't sure if you knew that trick, so wanted to explain it. Okay, problem number 4, or example 4, b minus 1 fraction bar divided by 2b minus 6, and then plus 5/3 as my second fraction. So I can try to split things up a little, see if I can factor. So I can pull out a 2 in this denominator of the first fraction. So I'm going to factor out 2 times b minus 3 is what I get. 2 quantity b minus 3 in the parentheses. Not sure that helps me so much. I need to get a common denominator. So I can add the fractions. So I need to think, what is my missing factors? So on the first denominator, I have 2 times quantity b minus 3. In the second denominator, I have a 3. So my LCD for this, or my lowest common denominator, is the product of the distinct factors. So I would have 2 times b minus 3, and then times the 3 on the second fraction. So my LCD is 6 times quantity b minus 3. So on the first fraction, all I'm missing for my other factor is a 3. So I'm just going to get that number out of the way. So I want to multiply my entire fraction by 3 over 3. It's like multiplying by 1. Because whenever I adjust a denominator to get the lowest common denominator, I need to adjust the numerator as well. Now on this second fraction, I need to multiply by the missing factor, which would be 2 times b minus 3 over itself. 2b minus 3. Or 2 times quantity b minus 3. Now I can distribute this 3 to the b minus 1. So I end up with 3 b minus 3 divided by 2 b minus 3 plus the 5 times 2 times quantity b minus 3 gives me 10 b minus 30, and then I have 2b minus 3 in the denominator. The next thing I want to do is keep my denominator that I worked so hard to get, the common denominator, in the bottom. So I'm writing that first under the division bar. But then in the numerator, I want to perform the operation. So I have a 3b plus a 10b, so I have a 13b. And then minus 3 minus 30 is minus 33. And I can look to see if I have anything I could factor out. I don't. So that would just be my answer, 13b minus 33, all divided by 2 times quantity b minus 3. You could put it back to 2b minus 6. That would be fine also. So number 5, I'd like you to try this one on your own. So this is a try it. The video try it. So it reads 4a with a fraction bar all divided by a plus 3 in the denominator minus a second fraction 4 with a fraction bar quantity a minus 3 in that denominator. So the first thing you have to figure out what the lowest common denominator is and how you got there, and then make equivalent fractions just like you would with numbers. So pause the video